Hello everyone. Welcome to this week's edition of CamLogic's Tech Tuesday. My name is Rob Carver and I'm an applications engineer at CamLogic. Tech Tuesday is our free weekly 30-minute tips and tricks webinar, and today's topic is feature-based machining with NX 8.5. But first, let's familiarize everyone with CamLogic. CamLogic has been in the CAD/CAM CAE space for over 35 years. The company was established 16 years ago and initially focused on CAM, servicing mainly the tool and die shops in the area. As the market has evolved, CamLogic has evolved. Interestingly, working our way backward from manufacturing to the conception of the idea or design. Because we started toward the end of the process and worked our way to the beginning, CamLogic has the fundamental knowledge of what has to be done to assure that each step of the process will result in a product that will actually work or fit into the next phase of development. CamLogic has chosen to represent software and tools that enable our customers to fulfill the full cycle of product development. We consider ourselves integrators and partners for our customers and not just resellers. CamLogic employs a three-legged stool strategy. We partner with Siemens, offering the complete integrated Siemens portfolio for design, machining analysis, and data storage and retrieval. We partner with 3D Systems for 3D printing and rapid prototyping, and Romer and Creaform for 3D scanning and for inspection and quality. Now that you've heard a bit about CamLogic, let's move on to today's topic, feature-based machining. Now this demo part is a typical machinery part, having many features common to any other machine part: drilled holes, tapped holes, pockets, that sort of thing. And feature-based machining is ideal for making programs automatically. We're using machining knowledge previously used to machine such features on other parts. So let me go to my demo. Okay. And we should, yep, okay, we see our demo part. Okay. And again, what we have here is a typical machinery part. This is a rather large part. If I were to remove this fixture and turn it over like that, a lot of you might recognize this as being a B-axis table for a palletized 4-axis machine. The system will recognize about 60 different feature types, which we'll show. NX CAM offers a lot of rules out of the box to create NC operations for the recognized features. It also offers a machine knowledge editor, sometimes you'll hear it called MKE, to customize the out-of-the-box rules or create new rules to machine the features. And we've got some parts already found in here, but it's important to understand that the features can be found all at one time, and your operations created all at one time. But for demonstration purposes, and I'll repeat this 2 or 3 times throughout the demo, that this is not normally how you would set up feature-based machining. Feature-based machining, however, is ideal for making programs automatically. We're using machining knowledge previously used to machine such features on that you've used to machine such features on other parts. What we're looking at first here is our operation navigator. In the geometry view shows us all of our operations, as well as other top-level objects like our workpiece, our NCS machine coordinate systems, any of the coordinate systems that we have here. And in the other operations, navigator views that we have are the program order. This is where we would order our feature to order our operations. The machining methods that are used, and here's our tool view. Okay, the various tools that are being used in these different operations. Let's go back to the geometry view for a second. The MCS machine coordinate system is the one that we would use to set up for our machine aligned to our simulation machine. Unfortunately, due to time constraints, we're not going to be able to run a simulation, but this is the coordinate system that would be aligned to your machine. The workpiece, let me expand that just a second. This is where we specify our finished part geometry. Okay. The blank geometry, if we can zoom in here a little bit, we'll see that the outline of a casting. I've got the casting hidden right now, but you'd see the outline of a casting here. The system uses that information to keep track of how much stock to remove, save tool paths, and that sort of thing. And finally, we have some check geometry. We're telling the system that under no circumstances do we want to hit our fixture. Okay. The MCS workpiece, this would be the fixture offset that we would use to set up our fixture offsets for rotation coordinate systems, that sort of thing. Each of these different MCSs that we have set up here, we're going to use to place our operations under. This is not a must, but it is helpful for plane transformations and CNC controllers and that sort of thing. Okay. In our again, our MCS machine goes to the simulation machine, and our MCS workpiece, once again, is the one that we use for our fixture offset for our NC output. And these other ones we would have set up as CSIS rotations for the 4-axis machine. Okay, let me expand some of these here. See that we already have some geometry found underneath here. We've got the step holes. We have a pocket shape, okay, that we've got here. We've got a milling path already created underneath there. We'll play that for a second. Okay, you see the system has automatically generated that tool path for us. It selected the tool based on machining rules. Okay. And these are all out-of-the-box knowledge rules. And really the only task the programmer actually has at this point is to generate the operation and then check the output. Okay. If I open up one of these other holes here, the system has looked at the feature to be machined. It has recognized that it's a hole. Let's look at this. These holes here. Recognize that it's a hole, and another rule has specified that it's going to use a spot drill and to start the hole in a drill to size. Okay. And it's picked the system has created the programmer didn't have to. The system created these operations and optimize and picked the order of machining. Later on, we can optimize our tool paths. Show you one more here. In this case here, we have these holes here, spot drill, X drill. That's this one down here. Okay. But the system using the knowledge base rules has created these pick the tools out of the existing tool library and created these operations for us. Let's go to our feature navigator. These are all the different features that the system has found so far. We're going to pick some more features here in a minute, or find some more features here in a minute. And NX can identify about 60 different feature types, as I said earlier, and we can find them all together in one step, or apply various filters to be more specific in finding the desired features, and we'll show that a little bit further in our demo. What we see in the list is features that we found by applying some of these specific filters. Okay. We can go through and pick some of these features out. Corner notches that are available. There's that pocket that we saw earlier. Okay. And the coordinate system by each feature is automatically defined, and it's what the system uses to determine which of those original those other NCSs, the top, bottom, face. It uses these coordinate system to determine which of those NCSs to place the feature operations under. The user, for whatever reason, can manipulate these coordinate systems and change the machining direction. Say on this hole here, okay. He can go ahead and flip the operator can go ahead and flip the direction, edit the feature CSYS. There's various other functions that he can do underneath this. But these operations can be edited very easily. The directions can be flipped very easily. But I'm not going to make any changes because I like the way it is right now. But just so that you know that these operations can be edited once the features are found and defined, it's very easy to manipulate these. Now, some of these features have the green check mark next to them. They have operations, generated operations already associated with them. Let's say in this one here that doesn't have a check mark, there's no feature operation or no operation or generated operation associated with it. But if we go down to the details list down here, let me expand that a little bit. For that one particular feature that it's found, there's a lot of information that's given about this feature, the X and Y and Z position of it, the depth of the pocket or the depth of that feature, the diameters available, that's in that feature, and what the programmer or what the normal operation would be, as a lot of you would probably know, is you would select each one of these, create each one of these features manually, operations manually. You'd have to step through making the decision what tool you want to use, get a blueprint or something out, define all this information, manually go through all of this for the various different hole sizes and stuff. But now, based on the machining knowledge rules, NX can create the operations for all the features, different sizes, all at once, making the tool selections completely automatic, making the process of program generation very easy for these type of features. We're going to select all of these features here. All right, got them all selected. Now we're going to create a feature process for all these features. See that our create feature process comes up. We have either rule-based or template-based. We're going to stick with the rule-based. As I said earlier, I may have mentioned earlier, I can't remember at the moment, but this works for turning wire EDM. In this case, we're going to use the mill and drill, and with the geometry set to automatic, it's going to automatically place the features under the appropriate MCS for us. So this will run for a minute or two. As you can see up here, it's creating the operations. In a minute, we will, like I said before, what you would normally do is you would do this, you would find all your features all at one time, you would create all your operations at one time, and then you would sit back and step through the output, see if there's any changes that you really do want to make. We're almost done here. The operations have been, we're now about 90%, 97%, 100%. Okay. Now you see that we have all these different operations created, all these different, and it's in our list. We have now operations that have not yet been generated. Okay. If we go back to our geometry, our operation navigator, we see that we have quite a few more of these step pocket, we have quite a few more of these geometry groups created. Okay. And we'll look underneath here. You see that we have, again, we've got spot drill and drills. The system went out and created the operation, selected the tools for us. What we have to do now is we have to generate it. I could select all of these step pockets at the same time, all at one time, and generate them all. Just for the sake of time, I'm only going to select a few, hit generate. Now keep in mind, I could have selected all of these operations and generated them, okay? But I'm not, just because I want to save some time here for the purposes of the demonstration. Notice that it's doing collision checking. If you notice up here, preparing for geometry for collision checking, okay. And then finally, gives me the chance to accept the paths on these. All right, now I could have just as easily done all of that at the same time with all of these other operations as well. Okay. And we've seen how easy it is to create and generate the operations. And so right now, let's go find some new features and apply some of these filters to the filtering operations. And it's kind of important to understand that we're finding a lot of these features somewhat manually in this demo, and it's only for demonstration purposes. And I said I was going to repeat this several times. It's only for demonstration purposes that we're doing it like this. In real life, you're going to find all your features at the same time, and you're going to do all your operations at the same time, and you're going to have a recognition library containing all the features for your most often machined parts. This is very customizable for your individual industry's needs. Okay. So now what I'm going to do, go up to the top here. This is my model. and I'm going to find the features. Okay, and I've got it set to parametric recognition. My search method is in the workpiece. Okay, and now we've got all these different filters that we can find, and I'm going to just uncheck these, and now that clears all the check marks. Now I can go through and I can find the different types of features that I want. Okay, so let me expand the corner notches, and I'm going to go and say I want to find corner notches, corner notch straight. Okay. Now come down here and click on Find Features. It's going to go through, look for the various features. Oh yeah, here we go. Okay, and you see that we've found 6 new features in here, highlighted in here. Now we've noticed that well, really don't want that surface there as part of my feature, so that's the one I'm going to delete that one. Okay, and so what's left are my 4 bearing pads. Okay. Now you see that I've got 5 features. Okay. And if I look, if I go back to my, okay. All right. Now if I go back to here, notice that 2 of them have a couple of plus signs in it. It's also detected that these features here have PMI data associated with it, or product manufacturing information. In this case, we've got 2 surface finish callouts on these particular surfaces. Okay. NX will not only recognize feature types, but it also finds this PMI information, and then by using the machining knowledge editor to create rules for operations, it will help determine what type of operation to apply to these and what type of tools to pick for these different types of PMI information. So with that, let's go back up, find some more features. Okay. Go back, find some more features. We got parametric recognition found. Again, make sure that we're set for workpiece. Uncheck this, and this time we're gonna look for some slots. Okay, let me collapse that. Go to the slots and look for slot rectangular. Okay, select that. And then when I hit Find Features, we're going to get a list of slot features that we found on the part. And as you can see, it highlighted these features. Okay. We're only going to really want to machine 2 of them. That one there, and not that. Oh, that little guy there. So we can get rid of everything else. Now we're left with that and that. Hit OK, and it's added those two. It's added those 2 features to our feature navigator. Okay. So now I'm going to all these new features that I've got. I'm going to create feature processes for them. Mill drill, hit OK. It's going to take a little bit of time here to create these operations, but it's going out, it's finding the appropriate tools, placing them under the appropriate MCSs. Okay, and I see that we've got operations. Now if we go back to our navigator, we'll see that we have some new operations or new feature groups under here. Okay. Now notice that two of these groups, even though they're the same type of feature groups, they've got, one has an additional operation underneath it. This is because of that PMI data that was attached to the geometry. Okay. Now we've seen with how easily with the use of feature recognition options and machining knowledge, say the NX is capable of handling, different feature types in different directions. It also takes care of PMI information with just a few clicks. We've established, we're using established strategies and tools from the library. Now, once we've created the NC operations, NX also offers the option to optimize the sequencing of the operations, and we can see how we can do this on some of the different program groups. Okay. So we see that we have in our program order view, we've got a lot of different spot drills underneath this spot drill operation group. Okay, we got a bunch of different tool transfers. We don't really need to take the transfers or anything into consideration. The system's going to handle all this for us. Okay, so highlight that, go to Object, Optimize. We're going to consolidate the tools, minimize our tool changes, and create optimization groups. And we see that we've got optimized NC groups. Now, obviously we need to generate these, but you can see that it's organized at the different spot drills into optimization groups for us. Simplified our tool path, our tool changes. We can generate these just by clicking that group. So we're generating, we're optimizing and generating all of our tools with just a few simple mouse clicks. Give this just a few minutes to run. Once again, the system went out, chose the correct tools, chose our transformations, avoided geometry. The programmer really just needed to do what I'm doing here, generate the tool paths and check the output. Post-process it, send it out to the machine, and start working on the next job. This is a fairly complex part, so it would take the normal processing of a job like this would take hours, if not days, to manually do this without using feature-based machining. As you can kind of see, it's bouncing through the different operations. You can see some of the tool paths flashing up there. Okay, we've optimized it. We're going to accept the paths. Okay. We can see the different tool paths for that spot drill. Okay. If I were to compare it to, say, drilling operation, you can see that it's taken care of optimizing a lot of the the shortest tool path for us. A lot of those decisions have been made for us. And with that pretty much concludes this demonstration. Let me go back to my PowerPoint. Now, we can't emphasize enough the importance of training to get the most out of today's technology. It's well documented that training helps improve the speed of use, increases efficiency, provides faster problem resolution, and leads to fewer support calls, all of which positively affect the company productivity, your return on investment, and the bottom line. At CamLogic, we offer a wide variety of hands-on instruction-intensive courses for users of every level. Training is available at the on-site location of your choice or one of our training labs located throughout the Midwest. For more information or to register, please visit our website. Today's webinar can be found on YouTube, usually within 24 hours of the broadcast. Check out CamLogic on YouTube for past webinars as well. And thank you for joining us today. If you have any questions, please feel free to email me. My contact information is there on the screen. Call me anytime. Be sure to visit our website at www.camlogic.com. We can also be found on LinkedIn, Blogger, Facebook, YouTube, and Twitter. And this concludes today's edition of Tech Tuesday. And thanks again for tuning in, and have a great day.